66 million years ago, something extraordinary happened beneath what is now the Indian subcontinent. Not an asteroid strike, not a sudden explosion, but a slow, relentless churning of the Earth's crust that would reshape the planet. Imagine a plume of superheated rock rising from deep in the mantle, like a blowtorch igniting the surface. This was the birth of the Deccan Traps, a volcanic furnace that would pour out more lava than anywhere in Earth's history. The ground split open, and the age of dinosaurs began its long, silent countdown. Beneath the surface, a mantle plume, a column of molten rock thousands of kilometers deep, rose with tremendous force. It punched through the tectonic plate sitting above it, creating a weak point in the crust. When the pressure finally broke through, it did not erupt in a single blast. Instead, it opened like a wound, a fissure hundreds of kilometers long. From this crack, layer upon layer of basaltic lava began to pour out, flowing across the land in waves that would last for hundreds of thousands of years. The lava that emerged was not thick and slow like the volcanoes we picture today. It was fluid, almost like motor oil, racing across the landscape at incredible speed. Each flow covered dozens of square kilometers before cooling into a new layer of rock. Over time, these flows stacked on top of each other, building a vast plateau of black basalt. At its peak, the Deccan Traps covered an area larger than the state of Texas, with lava flows reaching thicknesses of several kilometers. The land was buried alive beneath an ocean of fire. As the layers cooled and hardened, they formed a structure unlike anything else on Earth. The Deccan Traps were not a single mountain or caldera, but a sprawling, terraced formation of stepped cliffs and rolling plateaus. The weight of the lava was immense, pressing down on the crust and triggering earthquakes and tsunamis across the Indian Ocean. The very shape of the subcontinent was changing, lifted and distorted by the sheer mass of molten rock beneath it. But the lava was only part of the story. The eruptions also hurled vast clouds of ash, sulfur dioxide, and other gases high into the atmosphere. These plumes spread across the globe, darkening skies and altering weather patterns. Sunlight was blocked, temperatures dropped, and photosynthesis ground to a halt. The air itself became toxic, filled with particles that would linger for years. The world above was being poisoned by the very fires below. When the ashen gases settled, they did not simply disappear. Sulfur compounds mixed with rainwater, creating acid that fell across the land and sea. The oceans absorbed massive amounts of carbon dioxide, becoming more acidic and killing marine life in staggering numbers. The food chains that had sustained creatures for millions of years collapsed. In the depths of the sea, entire ecosystems vanished, their remains forming layers of black shale that would tell the story for eons. The extinction that followed was the most severe in Earth's history. 3/4 of all species disappeared, including the non-avian dinosaurs. But it was not an instant death. The effects of the Deccan Traps unfolded over hundreds of thousands of years, a slow unraveling of life on Earth. Forests withered, rivers ran dry, and the climate swung wildly between extremes. The planet was sick, and nothing was safe from the fever that consumed it. Scientists have long debated whether the asteroid impact or the volcanic activity was the primary killer. But recent dating of the Deccan Traps suggests that the eruptions were happening at almost exactly the same time as the impact. The two catastrophes may have overlapped, each making the other worse. The volcanic winter from the eruptions could have weakened ecosystems just as the impact winter from the asteroid delivered the final blow. Together, they created a 1-2 punch that life could not survive. To understand this ancient catastrophe, scientists turn to the rock layers left behind. Each layer of basalt tells a story of a single eruptive phase, and the ash beds between them record the passage of time. By measuring radioactive decay in minerals, researchers can date these layers with remarkable precision. The evidence shows that the most intense eruptions occurred in a narrow window of time, just before the extinction event. The rocks do not lie, and they speak of a world in crisis. When the eruptions finally ceased, the world was a different place. The climate stabilized, but the damage was done. Mammals, which had lived in the shadows of the dinosaurs, now had room to grow. The age of mammals was about to begin, and eventually, so too would the age of humans. The Deccan Trap stood as a monument to the power of the Earth itself, a reminder that our planet is shaped not just by gentle forces, but by catastrophes that can reset the clock of life. The story of the Deccan Traps is more than ancient history. It is a warning about the power of our planet's interior and the delicate balance of life on Earth. Today, as we face our own climate challenges, the lessons of the past become ever more relevant. The same forces that shaped the age of dinosaurs still operate beneath our feet, and understanding them helps us appreciate just how fragile and resilient life can be. The Deccan Traps remind us that the Earth is alive, restless, and capable of wonders and terrors beyond our imagination. Beneath the surface, the same molten fires that once darkened the skies still burn, shaping the fate of our world. What other secrets lie hidden in the deep past, waiting to be uncovered? The story of the dinosaurs is far from over, and the next chapter may hold even greater surprises. Beneath what is now Western India lies one of Earth's most dramatic volcanic events. The Deccan Traps, meaning Badlands of the Deccan Plateau, cover over 1.5 million square kilometers with layers of basalt. These eruptions began around 66.7 million years ago, spewing lava at an unprecedented rate. Over hundreds of thousands of years, they built a landscape of endless floodplains, burying ancient seas and forests under miles of cooling rock. Geological evidence reveals the Deccan Traps erupted in pulses, with the most violent phase occurring just before the Cretaceous-Paleogene boundary. Scientists estimate these eruptions released enough lava to fill the Grand Canyon every minute for a century. The timing is critical. The largest volcanic episode coincided precisely with the asteroid impact that ended the dinosaurs' reign. This overlap suggests multiple catastrophic forces converged in Earth's final Jurassic moments. The eruptions did more than melt rock, they choked the atmosphere. Massive plumes of sulfur dioxide and ash rose thousands of meters, scattering globally. These particles blocked sunlight, triggering an abrupt ice age known as volcanic winter. Photosynthesis collapsed as sunlight dimmed, collapsing food chains from the bottom up. Forests withered, oceans grew acidic, and the very air became toxic for many species. Beyond sulfur, the eruptions pumped staggering volumes of carbon dioxide into the atmosphere. CO2 levels surged, accelerating global warming even as sulfur-induced cooling gripped the planet. This double assault created climate instability unlike anything in Earth's history. Ocean currents shifted, weather patterns fractured, and temperature swings became extreme. Life struggled to adapt to conditions that swung between ice and heat in decades. Rising CO2 levels didn't just warm the atmosphere, they dissolved the oceans. As carbonated water seeped into marine environments, calcium carbonate shells and coral reefs began dissolving. The base of the marine food web faced annihilation. Plankton populations crashed, triggering cascading extinctions that rippled through every ocean ecosystem. This silent killer worked alongside fire and ice to unravel life's delicate balance. On land, the effects were equally devastating. Forests burned as volcanic lightning ignited dry undergrowth. Rivers carried toxic sediments to coastal areas, smothering estuaries and marshes. Herbivorous dinosaurs, already stressed by climate shifts, found their food sources vanishing. Predators followed their prey into decline. The very ground they walked on became unstable, with earthquakes triggered by magma movement beneath the crust. Rising sea levels, driven by thermal expansion and melting ice, swallowed low-lying coastal habitats. Dinosaur nesting grounds inundated, while vast tracts of habitat were permanently submerged. Marine transgression reshaped continents, turning once fertile plains into shallow seas. Species that couldn't migrate or adapt faced extinction. The geological record shows sudden disappearances of entire faunal assemblages in these vulnerable zones. As if Earth's volcanic fury weren't enough, a 10-kilometer-wide asteroid slammed into the Yucatan Peninsula at 20 kilometers per second. The impact vaporized rock, hurled debris into orbit, and created a global dust cloud. Combined with volcanic winter, this double catastrophe sealed the fate of non-avian dinosaurs. The planet entered a prolonged period of darkness, cold, and starvation that no creature could survive. Today, geologists read the story in stone. The KPG boundary layer contains iridium, a metal rare on Earth but abundant in asteroids, mixed with soot from global wildfires. Beneath it lie the final ash beds of the Deccan Traps. These layers tell of simultaneous destruction from above and below. Every rock sample from this epoch carries the scars of Earth's most violent chapter, preserving evidence of humanity's ancient birthplace's violent end. Not all life perished. Small mammals, birds, and reptiles survived in refugia, hidden pockets of stability. Their ability to thrive in darkness, eat insects, and burrow protected them from extinction. These survivors would inherit a changed world. Within millions of years, new species would rise from the ashes, eventually leading to the creatures that walk among us today. Extinction, as brutal as it was, became Earth's engine of renewal. The Deccan Traps remind us that Earth's history is written in catastrophe. Volcanic activity shaped climates long before humans arrived, proving that our planet's fate isn't tied to our actions alone. These ancient eruptions teach humility, showing how quickly life can unravel when forces beyond control take hold. Understanding them helps us grasp our place in a dynamic, ever-changing world. The flood basalts of the Deccan Traps stand as monuments to Earth's power. Their legacy is etched in stone, teaching us that extinction is not an end but a transformation. As we face our own climate challenges, these ancient events offer perspective, both warning and hope. The story continues, written not just in the past, but in every choice we make for our planet's future.